Hi Examiner, today I'll be talking about my data science project, and let's start off with domain specific area. So the domain here is public health and health informatics. The idea here is we want to gather and analyze data and use these results uh, of the analysis to uh, give to researchers, policymakers and authorities for them to make better decisions for the overall health and well-being of the population. As for the dataset I'll be using is from Kaggle. It's the Kaggle is the author sourced the datasets from the World Health Organization and the United Nations page. So why this dataset, right? So the reason for this dataset is uh, first, uh, it was sourced from the World Health Organization and United Nations, which is a credible and reliable source. And second is that it has this data actually has a wide range. It covers a wide range of countries, and and uh, factors and a lot of factors, cover a wide range of factors related to economy, social factors, and health related factors, right? So I feel like this data set is actually quite a good fit for for my goals and my objectives. So as I skim through the page, you see we start here I started after loading my data. I started doing data cleaning, and I identified the null values, and then I try to treat the null values with interpolation, but not all null values were treated. So after that, I try to replace these null values with mean or medium based on the skewness level of each column. After doing so, uh, I deal with the outliers, right? I try to use so to I created a detect outlier function to detect outliers, and use the sorry for the pronunciation, winsorization technique to remove these outliers. So after removing these outliers, I went to statistical analysis, and here I printed out a bunch of statistics of each column from things like mean, mode, medium, mean, minimum, and maximum. So based on this, we could generally tell what's the average, or the most people with a certain life expectancies. After that, I visualize. So for visualization, I plotted a scatter plot to try to find out like each how each column looks when against life expectancies. And here, we can see columns like adult mortality again. Life expectancy versus adult mortality actually has a very defined direction. Same with life expectancies and schooling. So after realizing this, I plotted a heat map, and this heat map. So the heat map will have correlation, correlation values against life expectancy, and based on my observation, schooling, income composition of resources, adult mortality, and and HIV/AIDS actually has strong correlation uh, against life expectancy, right? So now I start working on my ML model. So I decided to use all columns, other than columns that I cannot use, like country and status, to train my ML model, to use it to train my ML model. Oh, sorry, to create my model. After that, I use the model and I try to predict the life expectancies of based on the selected features, with schooling, income composition of resources, adult mortality, and HIV. And I plotted a scatter plot to see whether if the value the whether if the values is heading towards us the right direction. And overall, it seems quite accurate here. So after that, I use validation. So I use cross validation to to check, to evaluate my initial model. And these are the results I received. After this, I move on to feature engineer, and I use polynomial features to fit the features, right? So after applying polynomial features, I retrained my model and evaluated the new model. And I found that actually the new model actually has a lower mean square error and a higher R square value, which means that the new model is actually better than the initial model. So some challenges and limitations was probably data cleaning. So replacing things with mean and medium could actually sort of impacted how the correlation between different variables, because these are not actual values and they are using mean and medium. So it could in fact impact the performance of the machine learning models. And so some further improvements would be implementing more machine learning models, so that we can compare which machine learning models actually are better for this data set. Yeah, that's all for my video. Thank you for listening.